the eigenvectors corresponding to the eigenvalue lambda equal to 0 are formula A minus lambda I of x equal to O. O means null matrix. Lambda is, in this case, lambda value is 0. So replace A minus 0 into I of x equal to O. That is A x equal to O. A matrix 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3. X means scalar matrix. For this system of equations, see each row contains 3 values. So correspondingly take 3 variables x1, x2, x3. O means null matrix 0 0 0. First we should change the given matrix, this matrix into echelon form. To simplify, first interchange last row and first row. R1 interchange R3. So this is equivalent matrix of 2 minus 4 3 minus 6 7 minus 4 8 minus 6 2. x1 x2 x3 0 0 0. Next, by using row operations, we will change this matrix into echelon form. To change this element as 0, use R1 only. See, R2 implies, R2 contains first element as minus 6, R1 contains first element as 2. So R2 plus 3R1. Next, R3 row operation is, R3 contains 8, R1 contains 2. So R3 minus 4R1. It is the first operation, R2 plus 3R1. R2 values, minus 6, 7, minus 4. 3R1 values, 3R1 means 6, 3R1 means minus 12, 9. By adding these two, minus 6 plus 6, 7 minus 12, minus 5, minus 4 plus 9. So next R2 becomes 0, minus 5 and 5. Next R3 row operation is R3 minus 4R1. What is R3? 8 minus 6, 2. 4R1, 4 into 2, 4 into minus 4. Next 4 into 3. R3 minus 4R1. Subtract. 8 minus 8. Minus 6 plus 16. 10. Next 2 minus 12. This is 10. So last one is, last row is 0, 10, minus 10. See R3 and R2 and R3. They are multiples. Next step, use only R2. See R3, change this element as 0. R3 as R3 plus 2R2. Equivalent matrix is 2 minus 4, 3, 0 minus 5, 5, 0, minus 10. What is R3? 0, 10 minus 10. 2 R2 means 0, minus 10 plus 10. R3 plus 2R2 means 0 plus 0, 10 minus 10, minus 10 plus 2. So R3 is all zeros. R3 contains 0, 0, 0. Next, write the equivalent system of equations. The equivalent system of equations are 2 into x1 minus 4 into x2 plus 3 into x3 equal to 0. This is first equation. Next, second equation, 0 into x1 minus 5 into x2 plus 5 into x3 equal to 0. This is second equation. Second equation also can be written as, by common out, minus 5 x2 minus x3 equal to 0. This implies x2 equal to x3. Next, find the number of free variables. Here we got two equations. Unknowns means variables are 3. What is the difference? 3 minus 2, that is 1. So the number of free variables are 1. So we can choose one of these three variables. Choose x3 as k. From second equation, x2 equal to x3. So from second equation, x2 also k. From first equation, 2x1 equal to 4x2 minus 3x3. By replacing x2 and x3 values, 4k minus 3k. This value is k. 2x1 equal to k implies x1 equal to k by 2. So x1 k by 2, x2 k, x3 k. So the eigenvector or characteristic vector corresponding to the first eigenvalue lambda equal to 0 are, right, x1, x2, x3 values. K by 2, k, k. Common out k by 2. Since first value is fraction, common out k by 2, we can write 1, 2, 2. So vector 1, 2, 2 is the eigenvector corresponding to the eigenvalue lambda equal to 0. Next case 2, the eigenvectors corresponding to the eigenvalue lambda equal to 3 are formula a minus lambda I of x equal to O. That is, replace lambda by 3. A minus 3i of x equal to O. A minus 3i means diagonal elements of a minus 3. That is 8 minus 3 minus 6 2 minus 6 7 minus 3 minus 4 2 minus 4 3 minus 3. X means scalar matrix x1, x2, x3. O means null matrix 0, 0, 0. It is 8 minus 3, 5, minus 6, 2, minus 6, 7 minus 3, 4, minus 4, 2, minus 4, 3 minus 3, 0. x1, x2, x3. 0, 0, 0. To simplify this and changing into echelon form, first change the R1 and R3. That is 2 minus 4, 0, minus 6, 4, minus 4, 5 minus 6, 2 into x1, x2, x3 equal to 0, 0, 0. Next, change this element. Second row first element as 0 and third row first element as 0. What are the row operations? R2 implies R2 plus 3R1 and R3 implies, see, first row contains 2, third row contains 5. So multiply R3 with 2 and R1 with 5 and then subtract. What is the first row operation? 2 minus 4, 0. See, R2. R2 is minus 6, 4, minus 4. Next 3R1. 3R1 is 6, minus 12, 0. Add all these numbers. Minus 6 plus 6, 4 minus 12, minus 4 plus 0. for the first row operation. Next, second row operation. What is 2R3? 2R3 means 10 minus 12, 4. 5R1 means 5R1, 10 minus 20, 0. Subtract all these values. 10 minus 10, 0. Minus 12 plus 20, 8. 4 minus 0, 4. So R2 becomes 0 minus 8 minus 4. R3 becomes 0, 8, 4. Into x1, x2, x3 equal to 0, 0, 0. Next row operation, to change this element as 0, say R2 and R3, only signs are different. So add R3 plus R2. So equivalent matrix 2 minus 4, 0, 0 minus 8 minus 4, 0, 8 minus 8, 0, 4 minus 4, 0. Into x1, x2, x3 equal to 0, 0, 0. Next, write the equivalent system of equations. Clearly, this is in echelon form. First non-zero row, second one non-zero row, third one 0 row. First row contains no zero, second row contains 1 0, third row contains more than 1 zeros. So this is in echelon form. Next, write the equivalent system of equations. First one, 2x1 minus 4x2 plus 0x3 equal to 0. So this one equal to, simplify, divide with 2. x1 minus 2x2 equal to 0. This is first equation. Next, second, 0 into x1 minus 8x2 minus 4x3 equal to 0. Divide with minus 4. Common factor is minus 4. So 2x2 plus x3 equal to 0. This is second equation. We got 2 equations and 3 unknowns. So the difference is 1. The number of free variables equal to 1. So choose one of these 3 variables. Choose x3 as k. From second equation, 2x2 equal to minus x3. So 2x2 equal to minus k. x2 equal to minus k by 2. Next, from equation 1, x1 equal to 2x2. x1 equal to 2 into minus k by 2. So this value is minus k. x1 equal to minus k. Next, eigenvector x2 equal to x1, x2, x3. Replace the values. Next, common out minus k by 2. This is 2. Minus k by 2 into 2, minus k. Next, this is 1. Next, minus 2. Minus k by 2 into minus 2 is k. So, 2, 1, minus 2 vector is the eigenvector corresponding to the eigenvalue lambda equal to 3. Next, case 3. The eigenvectors corresponding to the eigenvalue lambda equal to 15 are a minus lambda I of x equal to O. Replace lambda by 15. A minus 15I of x equal to O. That is diagonal elements of A minus 15 into scalar matrix equal to O. So matrix 8 minus 15 minus 6 2 minus 6 7 minus 15 minus 4 2 minus 4 3 minus 15 into scalar matrix x1 x2 x3 equal to Null matrix 0, 0, 0. So this matrix becomes minus 7, minus 6, 2, minus 6, minus 8, minus 4, 2, minus 4, minus 12. Scalar matrix x1, x2, x3. Next, null matrix 0, 0, 0. Next, change this matrix into echelon form. First, interchange R1 and R3. Equivalent matrix is 2, minus 4, minus 12, minus 6, minus 8, minus 4, minus 7, minus 6, 2 into x1, x2, x3 equal to 0, 0, 0. Next, change minus 6 as 0 and minus 7 as 0. So, what is the row operation? Second row operation, R2 plus 3R1. Next, R3 implies, see, first row contains 2, third row contains minus 7. So, multiply R3 with 2. 2R3 plus 7R1. That is first one, R2. R2 is minus 6, minus 8, minus 4. Next, 3R1. 3R1 is 6, minus 12, minus 36. So, addition. Minus 6 plus 6, 0, minus 8, minus 12, minus 20, minus 36, minus 4, minus 40. Next row operation, what is 2R3? 2R3 is minus 14, minus 12, 4. Next 7R1 is 14, minus 28, minus 84. Next, addition. Minus 14 plus 14, 0. Minus 12, minus 28, minus 40, minus 84, plus 4, minus 80. So, replace the values in this matrix. 2, minus 4, minus 12. Next, second row becomes 0, minus 20, minus 40. Third row becomes 0, minus 40, minus 80 into scalar matrix x1, x2, x3. Null matrix 0, 0, 0. See, second row and third row. These are multiples. So, change R3 as R3 minus of 2 into R2. What is R3? 0, minus 40, minus 80. Next, what is 2R2? Multiply each element in R2 with 2. Next, 0, minus 40, minus 80. Subtraction, 0, minus 40 plus 40, 0, minus 80 plus 80, 0. So, third row becomes all zeros. 2, minus 4, minus 12, 0, minus 20, minus 40, 0, 0, 0 into scalar matrix x1, x2, x3. Null matrix 0, 0, 0. See, first row contains no zeros before non-zero element. Second row contains 1 0 before non-zero element. Third row contains more than 1 zeros. So, clearly this is in echelon form. So, next, write the equivalent system of equations. The equivalent system of equations are 2 into x1 minus 4 into x2 minus 12 into x3 equal to 0. Next, simplify this equation. So, 2 is the common factor. So, cancel 2. x1 minus 2, x2 minus 6, x3 equal to 0. This is first equation. Next, second equation, 0 into x1. Next, minus 20 into x2. Minus 40 into x3 equal to 0. Common number is minus 20. So, throughout, divide with minus 20. x2 plus 2, x3 equal to 0. So x2 can be written as minus 2x3. We have 2 equations and 3 unknowns. So the number of free variables are 1. So choose one of these 3 variables. Choose x3 as k. From second equation, x2 equal to minus 2x3. So this is minus 2k. From equation 1, x1 equal to 2x2 plus 6x3. So x1 equal to 2x2 means minus 4k plus 6x3 means 6k. This is 2k. So x1 2k, x2 minus 2k, x3 k. So x3 equal to, write x1, x2, x3 values. x1 is 2k, x2 is minus 2k, x3 is k. So common out k vector is 2 minus 2, 1. So the eigenvector corresponding to the eigenvalue lambda equal to 15 is 2 minus 2, 1. Today's session is over. No?